Hey guys, so I'm going to go through right now and show you how to do an example of all 10 questions from yesterday's MATHXL assignment, Thursday. It's the segment addition postulate. Now, I want to point out that in MATHXL, there's this question help button at the top right, and know that there's some really helpful tools here. You can click help me solve this example or this problem, and it'll kind of give you some pointers, walk you through some stuff. There's also this view an example little feature. So it's going to show you an example almost identical, and it's going to tell you how to do it. So know that if you're totally stuck and you can't ask someone, this is really nice. Okay, so take a look at that if you need it. So number one here, hopefully this one doesn't give you too much difficulty. You basically just have to say how long is this segment from A to B. Okay, I just kind of like covered up what I need to see here, but you can either count it, which is what I would probably just do. That seems to be pretty easy for people. Or you can take where A is located, -10, and take where B is located, and just subtract those two numbers. Either way you do it, doesn't matter. And then you take the absolute value of that. So 6 minus -10, that's actually adding 6 plus 10. So the absolute value of that, absolute value just makes a number positive. This is already positive, so the answer would be 16. And you type that in there. Sorry, I already went through and did this question, so that's why the number's already filled in. I got it right. Yay me. Okay. On the next one, same thing. I already went through and did this one. Sorry, guys. It is 44. Here's how I did it. So they told me that ST was 13. So from here to here is 13. And then they told me RT is 57. Well, RT is actually the entire segment. So I want to find how big is RS, which is the other piece. So the segment addition postulate just says if you add the two pieces together, it should equal the whole thing. So they gave me the whole thing, so I'm going to kind of like work backwards, and I'm going to take the whole thing minus this little piece, and that's going to give me that guy. So 57 minus 13, that's where I got my 44. That has to be this part right here. Like I said, hopefully those first two aren't terrible for you. Let's go on to number 3. All right, number 3 says use a number line, and again, they're giving me like some information about how long different parts are. So I'm going to label that on the picture. RS is 9y plus 5. ST is 5y plus 9, and then the entire thing from R to T is 16y minus 2. Okay, segment addition postulate says part plus part equals the whole thing. So I'm going to add the two parts together, that and that. And you have to bear with me on my screenwriting here. It is not great. I'm working on it. Add the two parts together, and that equals the whole thing, which is 16y minus 2. Then from there, I just need to combine some like terms. So this is just an algebra problem now. I'm solving it for y. So 9y plus 5y is 14y. I'm going to add the numbers together too. That would give me 14 equals 16y minus 2. I'm running out of room here, but I'm going to subtract 14y to get my y's together. Okay, let me bring my work up here. Let me do a different color. So I'm going to bring it up here. So that would leave me with 14 equals, let's see where I'm at, 2y minus 2. Then I'm going to add the 2 over. So that would be 16 equals 2y, and then divide by 2, my y value is just 8. Okay, that got a little messy. Hopefully you can follow the process. Oh, whoops. Didn't complete the whole thing. All right, notice there's a second part. Thank you, MathXL. How long is RS, ST, and RT? Well, now that you have Y, you can figure that out. So let's see. RS is the 9Y plus 5. So I'm just going to plug in my Y value, 8, into that expression and just do 9 times 8 plus 5. So that would be, let's see, 77. And then I'm going to do the same thing. So I'm not going to write it out, but guys, for ST, I would just do 5 times 8 plus 9 and get 49. So you're just substituting your Y value back in. And then same thing for RT. So I'm going to do 16 times 8 minus 2 and get 126. All right. Number 4. So number 4, use my number line. LN and MQ are congruent. So congruent means the same or equal. So let's see. Now they want to know, oh, they're asking me, sorry, are they congruent? But congruent still means the same. So LN is from here to here. You could just count how long it is. So it's, if you do that, be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so be careful there when you count it. Sometimes people screw that up. Every time you move, you start counting. MQ is from here to here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. You could do the subtraction thing or you could just count it. Either way, that really clearly shows me that those are both 9. So yes, they are congruent. All right. Number 5, use the figure to the right to find the value of PT. P is the midpoint. So my picture is like super small over here. These little marks on PT and PQ, that means congruent. So those two pieces are the same and T is right in the middle. So that also tells me that they're the same. So basically, if they tell me PT is 3x plus 3, and then they tell me TQ, those two pieces should be the same. So I'm not going to overcomplicate this. I'm just going to set these guys equal. And then it's just an algebra problem. You just got to solve that for x. So I would subtract 3x and get 3 equals 2x minus 7. Then add the 7. And 2x equals 10. Divide by 2, and hopefully you're okay with that last step. That's just algebra. X would be 5. I didn't answer the question though, so don't put 5 in there. That's not what they want. They want to know PT. So PT was this 3x plus 3. Well, if you know that x is 5, if you know that x is 5, you can just do 3 times 5 plus 3, so that would be 18. Read careful what they're asking you. It's really easy to kind of put the wrong thing. I almost did it. Okay, on a number line, the coordinates of x, y, and z and w are -6, -2, 1, and 5. Find the lengths of the two segments. Definitely draw a picture. Okay, on a number line, like here's 0. Positives go right, so 1, 2, 3, 4, 5. Here's where W is. And that's at 5. What else do I know? Okay, I know that Z is at 1. And then X and Y are at -6 and -2. So let me get those guys out there. So -1, -2, -3, -4, -5, -6. Don't do that. The struggle can be real sometimes. There we go. So -6. And then my other guy, here's my 0, was at -2. Okay, so draw a picture. That's always going to help you. Then I need to find the length of xy. So that's just right here. Guys, I count it. So I start here and I go 1, 2, 3, 4. You could do -2 minus -6, take the absolute value. Either way, you're going to get 4. ZW is over here. So that's again 1, 2, 3, 4. 5 minus 1, that's 4. Are the segments congruent? Definitely. They're both 4. All right, number 7. Ooh, I like these. Drop-down menu. A point that divides a line segment into 2 congruent segments. So it's just going to be the point that's right in the middle. So that's got to be the midpoint. Number 8, use a number line. And again, they're telling me these different pieces here. So you always want to go in and label. So RS is 7y plus 2. That's this guy. ST, we'll use a different color here, from here to here is 5y plus 7. And then the whole thing is 57 from R to T. So I want to figure out y. Okay, we had one like this before. This one's almost a little bit easier because there's not a y in the whole thing. But basically the segment addition postulate just says add the 2 parts together, set it equal to the whole thing, 57. So it's just an algebra problem. 7y plus 2 plus 5y plus 7 equals 57. Okay, combine your y's. 7 plus 5 is going to give you 12 y's. 2 plus 7 is going to give you 9. Then you just got to subtract the 9 and divide by the 12. So hopefully that algebra problem is not too difficult for you from there. But you should just get, when you divide by 12, sorry, I kind of ran out of room here, but y should be 4. And I already know they're going to ask me multiple parts here. So let me clear my stuff out so I have room. But y is 4. Yep, here they go. Then you got to plug in 4 to your different parts here. So RS 7y plus 2. So I'll write it out for you. So 7 times 4 plus 2. So you're just going to plug it in. So that's going to be 30. Okay, ST, same thing. I just do 5 times 4 plus 7, so 27. And then they're probably going to ask me the last guy. Oh, no, they didn't. Sweet. Okay, this next one. There's congruent marks. If there's 2 congruent marks, that means those 2 segments are the same. If there's 1 congruent mark, that means those 2 segments are the same. So if AD is 14, you guys, DC is also 14, because those both have 2 congruent marks on them. That's what that means. Then they tell me AC, so that's the whole thing. That guy is 3y minus 32. I know that that should be 28 long if I do 14 plus 14. So 28 is how long this 3y minus 32 should be. And I don't want to run out of room, but you would, or run out of time here, but you would just add 28 plus 32. Divide it by 3, and you should get 20. So that's just an algebra problem once it's set up. And then you'd plug it in. AC, I already know that's 28 if I add the 14 and the 14 together. DC should be 14. I covered that from the beginning. All right, last problem. Yay, drop-down menu. 2 segments have the same length. That means that they're congruent. Hopefully that's helpful.